Hi everybody, Mrs. Pesic here. Sorry I'm not able to be here with you, but we are looking at section 12.4, inscribed circles, and hopefully you all have your guided notes. So let's begin. The goals for this section are to find the measure of an inscribed angle and to use inscribed angles and their properties to solve problems. So let's take a look at what an inscribed angle is. An angle whose vertex is on a circle and whose sides contain chords of the circle would be called an inscribed angle. All right, so if someone is going to pause this video, for example, then you can take notes. Make sure you're pausing if I'm going too fast. So an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So for example, we would say that angle DEF is an inscribed angle, because the vertex is on the circle itself, and the two sides of the angle are chords of the circle. All right, we would say that arc DF here is the intercepted arc, and we would say that arc DF subtends the angle, subtends angle DEF. All right, so the intercepted arc is the arc created by the inscribed angle. And subtends just means an arc or a chord subtends an angle when its endpoints lie on the angle. All right, so we have this theorem about inscribed angles. The measure of an inscribed angle is half the measure of its intercepted arc. So the measure of angle ABC in these pictures is going to be 1/2 the measure of its intercepted arc AC. So let's take a look at an example of this. So if I have this circle, and let's say I draw in this inscribed angle, all right? If this inscribed angle, let's say, measures 40 degrees, then the arc is going to be twice that. It's going to be 80 degrees, because the measure of the angle is half of the measure of the subtended arc. All right, so the measure of the angle is 1/2 of the arc. Now remember, that's very different from what we were studying before when we were looking at central angles. So in central angles, if this angle measured 40 degrees, then this would be 40 degrees. This is an example of a central angle. This is an example of an inscribed angle. I hope you're noticing the difference. The difference is all about where is that vertex. The vertex here is right at the center. That's why it's called central angle. Whereas here, the vertex is on, that's supposed to say vertex is on the circle itself. All right, so let's move on. Let's take a look at this example. So find each measure. We're trying to find the measure of angle RST. So the measure of angle RST, let's see, we have, let's fill in what our angles are and what we know here. So in this picture, we see that angle SRU is 40 degrees. And so that means that the arc that subtends it, which would be this arc SU, is going to be what? Well, that's going to be double that. So that's going to be 80. Whereas here, we're asked to find the measure of angle RST. So that's this angle, RST. So what? That's an inscribed angle, right? The vertex S is on the circle. And so what is the arc associated with it? Well, that's this arc here, RT. And so if RT is 120, then what's going to be the measure of this inscribed angle? Well, it's going to have to be half of that. So that's going to be 60 degrees. So angle RST measures 60 degrees. How about the measure of arc SU? We already showed that that's going to be 80 degrees. Put degree symbol up there. All right, let's take a look at our next example. Again, feel free to pause this as needed. All right, let's try in this one. We're going to find each measure. We're going to find the measure of angle DAE first. So I see the angle DAE is an inscribed angle, And if this arc here subtends that angle, and that's 76, well, then this angle is going to have to be half of that. So half of 76 is 38 degrees. So that should be the measure of angle DAE. And then what about the measure of arc ADC? Well, this one's going to be a little interesting because we are going from right here, A. What arc do we want? We want to start at A, go through D, and end up all the way over here at C. Well, that's a big arc, but I think there is one angle that subtends it that we know, and that's angle ABC. That subtends that, and that angle measures 135 degrees. I'll just write that right in here. That's this angle right here, and that means that this big arc that I drew in, that's this whole arc, is going to have to be, it's going to have to be double that 135. So 135 times 2 is 270 degrees. So that's the measure of this entire arc here, arc ADC. It's 270 degrees. All right, so that brings up this corollary. If inscribed angles of a circle intercept the same arc or are subtended by the same chord or arc, then the angles are going to be congruent. So let's take a look at our picture. We have angle ACB. Draw over this one. Angle ACB is right here. Angle ADB is right here. And angle AEB is right here. And all three of those inscribed angles have the same associated arc. They all subtend this arc here, arc AB. So like if arc AB, for example, was, I don't know, 70 degrees, then all three of these angles would have to be the same. They'd all be 35 degrees, 35 degrees, 35 degrees. So that's what they mean by all the angles are going to be congruent. All right. Again, feel free to pause if you need to. All right, let's take a look at this. We are trying to, let's get back to my picture. We are trying to find the measure of angle DEC if the measure of angle the measure of arc AD is equal to 86 degrees. So we see a circle here, and arc AD, which kind of goes from here to here, that arc measures 86 degrees, and this little angle, you can see this right here, that little angle is 60 degrees. All right, so let me get rid of this. So let's make a little bit simpler picture. So let me kind of get rid of all this scribble that I did. And so in this simpler picture that we have our angle BAC, which is 60. So I'm going to write that in right here, scribble that out so it's a little clearer. And we see that this arc here is 86. All right, and I'm going to write that a little bit bigger over here. So that's 86 degrees. So in this case, we're supposed to find the measure of angle DEC. That's this angle. That looks a little tough. Let's think about this. Well, if we know an arc that measures 86 degrees on our circle, is there an inscribed angle associated with that arc? Why, yes, there is. This angle ABC, this angle here, subtends that arc AD. So if this angle measures this arc measures 86, then this angle is going to have to be half of that, so that angle is going to be 43 degrees. All right, that's good. We know that, and we already know that this angle here is 60 right here. So if we take the 60-degree angle and the 43-degree angle and add those together and subtract from 180, we're going to get this angle, right? Angle AEB. So 60 and 43 add up to 103, and then if I subtract that from 180, I would get 77, wouldn't I? So I think this angle right here measures 77 degrees, and then these angles are congruent, as you know, because they are vertical angles. So I'm going to go with measure of angle DEC is going to be 77 degrees. All right, again, pause if you need to. Let's take a look at the next example, or I should say the next theorem. So an inscribed angle subtends a semicircle if and only if the angle is a right angle. So if I have an inscribed angle, let me draw another picture. If I have an inscribed angle, let's say my inscribed angle looks like this, and if I know for a fact that this is a right angle, this inscribed angle, then that tells me that it subtends a semicircle. In other words, this would have to be a diameter, and then this would be the semicircle here. All right? And it goes the other way also. So what I mean by the other way is because of the if and only if in this, let me draw another picture. If, for example, I know that I have a diameter, and that means I know I have a semicircle, then any angle, any inscribed angle I draw that subtends that semicircle, like for example, maybe this one right here, this angle here is going to have to be a right angle. So semicircles and right angles that inscribe are related to each other in that way. So an inscribed angle subtends a semicircle if and only if the angle is a right angle. All right, so let's take a look at this first example here. We are going to try and find x in this picture. Well, what do we notice? We notice, first of all, that we're assuming that S is the center. We can assume that if they put a big point like that, and that RT is a diameter. So if RT is a diameter, then that means that this arc here is going to be a semicircle. And if that's a semicircle, then this angle here that subtends that arc is going to be a right angle. So if I know that's a right angle, then 4x plus 6 has to equal 90, and I can solve for x. I subtract 6, I get 4x equals 84, and then I divide both sides by 4, and I get x equals 21. Feel free to pause if you need to get all this good stuff down. All right, let's take a look at this other picture. In this other picture, we have this diagram, and in this diagram, we are trying to find the value of y. All right, well, what do we know? We know that this angle here, angle ABC, measures 10y minus 28, and we also know that that angle is an inscribed angle. I'm going to kind of trace over that angle here, tracing over that. Okay, and then we also know that angle ADC here measures 7y minus 1. I'm going to trace over that angle here. So this angle, CDA, and this angle up here, CBA, they both are inscribed angles, but not only that, they both subtend the same arc AC. Well, if they subtend the same arc, that tells us, according to our theorem, that those two angles have to be congruent. Well, if they have to be congruent, then we can set 10y minus 28 equal to 7y minus 1 and solve for y. Because those angles have to be congruent. Those inscribed angles subtend the same arc. So I'm going to subtract 7y from both sides, and I'm going to add 28 to both sides. So I'm getting 3y equals 27. And then if I divide by 3, I get y equals 9 is my answer. All right. All right, let's take a look at this next theorem. All right. So in this theorem, it says if a quadrilateral is inscribed in a circle. Wow, and you thought we were done with quadrilaterals. If a quadrilateral is inscribed in a circle, then its opposite angles are going to be supplementary. So here's our hypothesis that we have quadrilateral ABCD inscribed in circle E. All right, well, they didn't draw in point E, but point E must be our center. And so our conclusion then is that angle A and angle C are not congruent, but they are supplementary. And angle B and angle D are going to be supplementary. And as you know, the four angles of a quadrilateral, of a convex quadrilateral, have to add up to 360. So these two angles here are going to add up to 180. These two angles here are going to add up to 180. And altogether then we'll have 360. Let's take a look at an example of using this theorem. Again, pause if you need to. Okay, so we are going to find the angle measures of this quadrilateral PQRS. So what do we notice? First of all, we see that this quadrilateral is inscribed in a circle. By the way, that means that all four vertices of this quadrilateral lie on the circle itself. All right? So in that case, we can see that angle P and angle R are across from each other, right? That means that they are going to be what? Not congruent, they're going to be supplementary. So I can set up 6y plus 1 plus 10y plus 19 equals 180. And let's solve. That gives me 16y plus 20 equals 180. And then I'm going to subtract 20 from both sides. And I'm going to get 16y equals 160. And then if I divide both sides by 16, I would get y equals 10. So I found the value of y. But remember, we're supposed to find all the angle measures. So can we plug in 10 for all of the values of y? So if I plug in 10 here, I get 6 times 10 plus 1. That's 61 degrees. So I'm going to fill that in, 61 degrees for angle P. And if I fill in 10 here, I get 10 times 10 plus 19. That's 119 degrees. Okay, those two are supplementary. That's good, 61 and 119. And then if we know that y is 10, we can plug that in here and get 10 squared plus 48. 10 squared is 100, so that would give us 148 degrees here. And then angle S is across from angle Q. So what do we know about angle S and angle Q? Well, we know that they are supplementary, so I can do 180 minus 148. And when I do that, I end up getting 32 degrees. So angle S measures 32 degrees. So for my answer, I would say measure of angle P equals 61, measure of angle R equals 119 degrees. That's supposed to be an R. Wow, let's try that again. Measure of angle R equals 119. Measure of angle Q equals 148. And the measure of angle S equals 32 degrees. All right, again, these were across from each other, and they're supplementary. These were across from each other, and they are supplementary. And if we add all four angles together, we should get 360, as we should in a convex quadrilateral. All right, so that's it for this lesson. You have a worksheet to do, and you have this homework assignment. So the worksheet is classwork, so you should work on that first, and then the homework assignment. All right, so thanks for watching, and have a great day.